Welcome back to Air Quality Matters, and I believe we already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Jack Harvie-Clark, founder and managing director of Apex Acoustics. If you've been around ventilation long enough, or read papers and research on the installed performance of ventilation, you will know the critical part acoustics has to play in outcomes out there in the real world. Yet for me, like many others, it feels like a bit of a dark art, strange terminology and an unfamiliar science to apply in the field for us practitioners. This is why I love talking to Jack. He has deep sector knowledge here and experience, and is founder of one of the most respected consultants in the UK, Apex. He advises the government and has been deeply involved in the development of guidance in both the UK and internationally, including on ventilation. But most importantly, he brings this subject to life in plain English and shines a light on this subject matter. We talk about the health impacts of noise in our environment and the impacts and influence it has on ventilation and much more besides. Do check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Jack Harvie-Clark. I've been really excited about this conversation because I love our chats anyway, but I think it's such an impactful part of the ventilation and air quality piece in the built environment. But at the same time, I've also been really nervous about this conversation because I'm immediately into an area I know almost nothing about. And I think that's why it's so important, because I think that there's a lot of people like me in one field of air quality and ventilation that knows acoustics and sound is important. And there's these numbers floating around. But beyond that, there's not a lot of people have an understanding of why this is important. So for me, I'll be really looking forward to this. And I think it's a really interesting conversation to be had. But perhaps, so go easy on me, will you, Jack, for starters?
Because it's exactly the same for me, because I'm equally interested, because I obviously think about things from a sound point of view, but realise how much we need to understand about people's environmental conditions and how air quality feeds into that. And how much more there is to, how many disciplines contribute to that is sometimes frightening. So what we need to know is more than anybody can know.
Welcome to the built environment, I suppose, a multidisciplinary space. You know, we talk about multidisciplinarity within the built environment, within air quality even. But when we start to talk about indoor environmental quality and we introduce air quality, sound, light, thermal comfort, you realise this is a really big playing field to try and navigate, isn't it?
Absolutely.
Yeah. So fundamentally, why do we care about sound other than it being an annoyance if it's not nice or great if it's not present in some way? There is an impact on health with sound, isn't there? I mean, fundamentally, this is important for human health and well-being.
Well, from so many different angles that we need to care about sound. So I think when you're referring to the impact of sound on health, that's transportation noise is where we know most about the adverse impacts of sound on health. And World Health Organization published guidelines in 2018 that brought all the information together through meta-studies. And so we absolutely do know how transportation noise affects people's health in their homes. And more recent work by Ben Fenwick from the UK Health Security Agency and his team have mapped the adverse impacts, the health burden of sound or noise on people across the UK. And the biggest health effect there is annoyance, followed by sleep disturbance. But we can also detect the effect on cardiometabolic diseases, so heart disease, diabetes, stroke. They're all associated with higher levels of road traffic noise.
Interesting. And is that causation or correlation? Because with road traffic noise, I guess, comes other things like pollutants.
Air quality pollutants, of course.
Air quality pollutants, yeah,
people
exactly.
often ask that question. And absolutely, the scientists who study this, I don't know how, but they say they are able to distinguish between air quality effects and noise effects. So yes, no, it is, as I understand it, causation, not just correlation. And the way, when we talk about the way noise affects health, there's two pathways. There's what we call the direct pathway. So that's the effect of noise on our physiology, if you like. So it raises your heart rate when you hit. So your body responds to events, noise events in the night or the daytime, raises your heart rate. And if your heart rate is raised, then you're going to be more at risk of all sorts of metabolic diseases. And then there's the indirect pathway, which is what you think about it, how you might respond, how it makes you feel, how annoyed you get by it. So annoyance is something that many people struggle as a kind of concrete health effect alongside heart disease and stroke. But that's where the World Health Organization puts it. Absolutely. So it is something we do need to take seriously. And obviously because it's very subjective. People respond very differently. So it's not that an equal dose has an equal response for different people at all. So we can only know these things at population level. And in fact, we know that the noise level or the sound level can only explain 1/3 of the annoyance, the variance in the annoyance. So we think we can explain another 1/3 of the variance with non-acoustic factors, which are starting to be documented and described in more and more detail. But that would still, and I could mention those, but that still leaves another 1/3 of the variance in annoyance, which is unexplained.
Okay.
So the non-acoustic factors are classified as personal factors. That's your personal ability to cope with noise. Your personal circumstances or ability. So that would stay relatively stable with you over time. I'm just hesitating slightly because I just had an email yesterday saying about how the descriptions of these classifications are changing right now as we speak.
So this is hot off the press. Okay. Yeah.
So there's the what they're calling situational or physical environment factors, which they count as things like, do you have a quiet side to your dwelling? So if you have a quiet side, you can understand you're likely to be much less annoyed by the noise because you've got some respite from it. If you can open the windows on the quiet side and have access to the outside without the noise. So that would kind of seem fairly obvious. Then there's things like if you've actually got a view of greenery rather than the road, then you're less annoyed by it. And if you can't see the road at all, actually, you're generally less annoyed by it. So they've had examples of where people have built noise barriers with clear parts so you can still see the traffic, and they haven't reduced the annoyance at all. And part of that is due to people's expectations. They thought it was going to get better. They will have reduced the sound level, but they don't reduce the annoyance. So the effect on people's health potentially hasn't been that great. So people's expectations are important for that type of thing. That would maybe be a personal factor, or maybe a social factor. So the social factors are things which are where we have shared perceptions with other members of the community. And examples of the examples often given are things like attitude towards the noise authorities. So what that means is things like round busy airports, the noise authorities, they will change the pattern of flights, the direction where they take off and land in at different times of the day to give people respite from the flights. And if you trust that the authorities are doing that fairly, you're much less annoyed by their noise, like much, much less annoyed. If you don't trust them, you're much, much more annoyed by the noise.
Yeah. Isn't it funny how fairness is such a powerful influencer on perception?
Yeah. But this is where it affects our health, because this is what affects your annoyance, which is directly linked to your health. So yeah, absolutely. So the perception of fairness is crucial for your health.
And is it a massive oversimplification just to say that this annoyance factor effectively is just a stressor, that your level of annoyance to sound is something that just creates stress in the body, and like all stress, it has a negative impact physiologically and on your mental health and well-being? Is that what we mean by annoyance? Is that background level of this is irritating? Is it as simple as that, to say something is annoying over time that does you harm?
Probably. So that's, again, outside my field. What you said sounds sensible. And it might also change your behavior, of course. It might mean you don't go to bed until later because there's certain sounds going on. Or it might mean you sleep somewhere else because of the noise. So it might, your part of your response in your annoyance might be to change what you do. But yes, I think you're probably right in that the
annoyance thing I can kind of get, but I also can understand how that might seem quite woolly. But the because it's like you say, it's a perception thing, and like a lot of risk, people's tolerance to things is different as well. But the physiological part of it is interesting to me, because it's not having a toxicological impact like air quality would necessarily, but I can perhaps at a stretch understand how, like you say, if it disturbs sleep or your brain interprets different noises differently and creates some kind of basal instinct, that we don't have control over. Like you say, it raises heart rate, fight or flight, all of these kind of things we understand with our chemistry.
The importance of that, of course, is that's the reason for our hearing in the first place, is to keep us safe. Because you don't have ear lids. You don't ever turn your hearing off. Your hearing is there to protect you from being attacked.
Yeah.
So your part of your hearing is wired into your nervous system at a very basic level. So it affects you in a very this is not responses that you think about and consider, but in a very basic way. So the sound is hardwired into our brains in a way in which it's designed to cause us stress. That's what it's for, because it's arousal. It's to arouse us so that we're ready.
Yeah, and I think anybody that's been in that half sleep state and there's an unusual noise and you get that jolt, exactly, and your body's immediately in fight or flight mode. It's a very unsettling experience. Like I think most people can appreciate how impactful that kind of basic instinct is of sound.
Yeah. So what your body will do to keep you alive in the short term has long-term impacts on you.
Yeah. So, I mean, I imagine that's a fascinating rabbit hole to start studying and research, but I think that's neither you or I's area of expertise at all. But from a sound perspective, I'm guessing there are different qualities of sound and different types of sound in our built environment that have different types of effects. To oversimplify, I'm guessing all of a sudden something makes a big banging noise in your built environment. That's going to be a startling sound that might have an impact on you, or sirens or horns going on outside will have an impact on you. But is there also impacts in that kind of white noise, background noise, more sustained level of sound in our built environment on our health? Do you know? Are we just talking about the startling types of sound, or the sound that's outside of the norms that cause an impact? Or can you have a low background level of something that's causing you harm as well? I guess a equivalence to chronic and acute air quality impacts. Like,
Okay.
yeah, do you know what I mean?
Yeah, absolutely. So road traffic noise that's steady absolutely has an effect on people. So the answer is yes. So the mechanisms might be slightly different in terms of it. This isn't something, an event that happens that causes an immediate response like that. But the presence of road traffic noise absolutely causes these effects. So it's the continuous sound at continuous levels.
Is it like air quality? There's just so much evidence around traffic, whether it comes to air pollution, noise pollution, that it just seems like a very well studied field. So is that where a lot of this evidence is coming from? Is people in urban environments, studies in urban environments and traffic noise? Or?
I mean, a lot of this evidence really is from the past two or 3 decades, really, 2.5 decades. Something that's just come to light recently that kind of fundamentally changes our understanding, actually, of how, well, my understanding, obviously other people understood this before, but that we have this strong narrative in the acoustics community that if you reduce the external noise levels from outside to inside, then you've mitigated the adverse effects from the noise. So at the minute, our national standard, BS 8233, contains guidelines on internal noise levels, and it quotes 35 dBA in the daytime and 30 dBA at night time. And we believe if we have a closed window strategy and achieve those levels, we've mitigated the effects of the noise. So our practice is kind of out of step with actually all the research on noise and health, which is all based on noise levels outside, not inside. And what has become apparent recently is that actually, for the same sound level inside, people feel very differently. If on the one hand they have their windows open, if they can have their windows open and achieve 35 dBA in the inside, they feel very differently than if they have to have their windows closed because it's noisier outside to achieve the same sound level inside. So people's experience inside of the sound is also influenced by whether or not they have to keep the windows closed to achieve it. And they feel much worse, as you can imagine. It's much more annoying if you have to keep the windows closed, even though you have the same sound level inside. So you can't entirely mitigate these effects by providing good sound insulation at the facade of buildings. People want to be able to open their windows without feeling the kind of the pressure of the noise from outside is preventing them, dissuading them from doing so. So this means noise is having an effect on you, even though you, in one sense, you can't hear it, because it prevents you opening your window and connecting, using your dwelling, connecting with the outside world in that way. So this is entirely, an indirect pathway, I'd say, for how noise is affecting people, but it's still affecting their health.
Geez, bloody complex, isn't it? Yeah, really fascinating. One of the problems I'm having mentally is it is subjective, and that is trying to put myself in a position where I can understand that level of annoyance or not. And being in the built environment for years, I kind of already know that my tolerance of noise is different to somebody else's and so on. But the numbers don't mean anything to me either. I can't picture the difference between 35 dBA with the window open and 35 dBA with the window shut. I find it very hard to put myself into a place where...
Well, that sounds the same.
Yeah, it sounds the same, but it's having a different impact. But I can't I'm not thinking in terms of acoustics enough to have a mental picture of what 30 dBA sounds and feels like to me day to day. You know, and I've seen all these charts of this
quiet.
is a whisper.
Think quiet. So if to get an idea of that, you can think that it's noisy outside, but if you shut the window, it's nice and quiet.
Yeah.
So shutting the window gives you a sense of relief. And that's fine until you feel like you want to open the window.
Yeah, there's an interesting point. And we have this the same in air quality, is that you build up tolerance to something in a space, and a change in that creates a reaction. So, for example, going from one space to another, you might perceive comfort differently compared to if you're in that space. Likewise, that noise might be tolerable to you with the window closed. You open the window and you realize that it's much noisier. You close it again, and now you're hearing that noise for the first time. A bit like going down to your kitchen in the middle of the night and hearing your fridge and wondering what that noise is, because you just don't perceive it and hear it during the day. There's other stuff like it's that trying to quantify what good looks like for people that aren't acoustic people is a really hard mental leap, I think. And I think you can probably tell I'm reaching for narratives here clumsily, and that's because it's a strange world to try and describe.
Well, I think what I'm talking about here is how people feel in their environment. And what we need to realize, so much of that is so strongly influenced by our sense of control over our environment. We know it's really important as human beings to have a sense of control over our environment. And I think when we feel like we can't close the window, can't open the window, or don't want to open the window because there's bad things will happen, or be uncomfortable, that feels like a kind of pressure on us. So this isn't really acoustics at all. This is about environmental comfort or environmental psychology, really. And it's just the way that noise has this pressure on that sense of how we feel. But it's not actually the noise, because, like I say, 35 dBA with the window open might sound the same as 35 dBA with the windows closed, with different noise environments outside. So it's nothing to do with hearing. It's to do with our sense of how comfortable we feel and where our comfort comes from in a space.
But this stuff is important, right? I mean, we talked about the burden of disease at the beginning as the reason why we're spending time talking about it here, and it's such a big effort externally to look at acoustics, is this has a burden of disease impact on society, doesn't it? Acoustic
Absolutely.
issues.
So noise is the second biggest burden of environmental disease after air quality. So.
And have we started to translate that into things like, people that listen to this podcast will have heard me talking about things like DALYs, disability adjusted life years. Have we started to translate the burden of disease from noise to those kind of numbers? And do you have any sense of what they are, what comparatively to other things?
I do.
Off the top of your head? Yeah.
With the latest conference paper that I did last summer with Ben Fennick, he did the translation into DALYs of the noise exposure at different levels from road traffic, rail traffic and air traffic. So absolutely, we can do that for transportation noise sources. We can express the health burden in terms of DALYs. And we can have the DALYs from the different health burdens as well, from annoyance, from sleep disturbance, from the ischemic heart disease, and so on. They can all be quantified.
So that's the same as with air quality. We're now starting to join the dots from burden of disease to cost of health and the ROI of getting this right. You know, we can start to put numbers around this thing to say, look, it's worth investment and resource to improve these outcomes because this is the burden of disease of.
So that's exactly what we did, is put the cost in pounds and pence on these health burdens, which then asks a really interesting question: who should pay for that? Because at the minute we essentially privatize the gain, the uplift in the land value when you get planning permission. That goes to the landowner. But society picks up the health cost, the occupants in society, the NHS picks up the health cost of the people who have to live in places that are exposed to high sound levels. So why doesn't the developer put some money aside to mitigate the health of those people, for example? But I know that the schemes like that are very complex and complicated.
Are you starting to see, as we're seeing within air quality, an impact of things like ESG and EU taxonomies and things starting to frame and value real estate beyond just land values and increasingly towards health and well-being and impacts on community and so on? Do you get any sense that acoustics is ratcheting up the importance scale as a result of those kind of more global factors where people are going, well, hang on a minute, this asset is going to be valued on more than just the building in 30 years' time. It's going to be valued on its impact on community and health and well-being and some other things as well. Do you see any of that in acoustics?
Not directly. Of course, it's in WELL and LEED and some of those classification systems. So there's something to do there, but that's, I feel like, quite box ticking type activity. And I don't usually, I think there's lots of opportunities actually that aren't taken at the minute to do a lot of work around sound and community and people, because it's a way of engaging with people over what they want and what they can manage, what they don't want, what they don't like, and bringing people together to do those things. So I think it works really well using a soundscape approach, which means kind of dealing with sound as more of a social phenomenon. Human-centric design, basically, for sound can work really well and absolutely tick all those ESG type boxes. And social value boxes, but that's not quite happening yet.
Interesting.
I keep sowing those seeds, but none of them have quite grown into oak trees yet.
As do I, and I think I probably talk a better game than's actually happening out there in reality when it comes to air quality. But nonetheless, I mean, there are some small ripples, I think, in the sector where conversations are happening around, well, under the EU social taxonomy, we're starting to see them trying to figure out how to frame this as they did with the taxonomy. So we'll see. Be an interesting one. I suppose bringing it back into lane a little bit on ventilation and air quality. There's no doubt from my experience that sound is one of the biggest influencing factors when it comes to outcomes of ventilation in our built environment, without question. It's probably the number one reason why stuff gets turned off or blocked up beyond comfort concerns. And it's something that needs to be far better understood, I think, within the ventilation community, the part sound plays in outcomes, sustainable ventilation long term. What are your kind of thoughts on where we are today with ventilation systems and sound? Because you wrote were part of a group that wrote a very important piece around ventilation and acoustics there. It seems only yesterday, but it was probably a few years ago now, wasn't it? That
yes, you're probably talking about our paper, which was How Loud is Too Loud? Noise from Domestic Mechanical Ventilation Systems. That was published in the International Journal of Ventilation.
Yes.
Which was 2019, I think.
Oh, God. Okay, yeah. Yeah. What's your kind of sense of where we are today? Because there's a lot of numbers appearing in standards that not many people really understand what they mean or the consequences of them. But like, as of today, like, what's your sense?
One thing I think that's really exciting about this is that more people are getting interested in this. So when I and my colleagues wrote that, we were really scratching around for information about things, as you say, because we'd heard lots of anecdotal information, evidence about people turning off their ventilation systems because they were too noisy. So this is a completely different effect of sound on people's behaviour compared to environmental sound, because this is the sound being annoying and you responding by controlling it, turning it off, which is, as you say, far too common. And I think the other most common reason that I've come across for people turning off their ventilation systems is because they think it's costing them money, is the other big one. But so when we wrote that we were struggling to find much direct research on this question about how sound affects people in their homes. There's quite a lot of research has been over the years about sound effect on people in offices, for example, because people are interested in productivity and all the rest of it. But there had been very little research on sound in people's homes. To the extent that the only direct evidence we could find of people measuring sound levels and asking people how they felt about the sounds was from a small study in the early, or maybe in the mid-2000s in Finland, when they were investigating compliance with the Finnish building regulations that had airflow rate requirements and sound level limits. And so then they could chart sound levels as they measured them and people's reaction to those. And what they found was people were dissatisfied with levels that we would never have thought we needed to design to. And people's immediate response is, oh, well, Finland, that's all rural and quiet, isn't it? But this was urban locations as well as rural locations. And it, below a certain level, if your ventilation system might be the loudest thing. If you have good sound insulation from outside, that's the thing that you're going to hear most significantly. So you don't need to be in a very quiet area to hear that. And so what we found then when we looked at it was that actually quite a few countries had evolved this problem with noise from ventilation systems. And I say evolved because I think until the 1970s, really, nobody worried about insulating or making their homes airtight, particularly. And then we had the energy crisis and everybody realized we're leaking money by leaking heat, and we needed to make our houses more airtight. And that's obviously what's led to the problem with indoor air quality. And the resolution to that was always supposed to be ventilation systems. And in countries that have a longer history of installing and maintaining ventilation systems, where it's more a part of the culture, if you like Sweden and Germany, for example, then we don't see the problems that countries that have more recently adopted mechanical ventilation having. So where people expect to see ventilation systems and rely on them, they make them work and they keep them quiet. In that we saw the same thing in the Netherlands as we have seen in the UK, is where there's been a rapid adoption of mechanical ventilation systems, but nobody really quite taking them seriously or knowing how to design them, which you've obviously seen in great detail. And we've seen failures at every part of the industry, I think, from the regulations themselves to lack of design, lack of specification, problems in procurement, in installation, commissioning, and operation and maintenance. Every part of
it's a long list. Yeah.
I think everybody who looks at any part of that, the whole, everything that contributes to getting ventilation systems working in practice, you have big problems in this country. And noise is the thing that kind of can happen at the end of all those failures, which mean people turn it off because it's too noisy.
Or commission it to a noise level that they think is going to be satisfactory, which in turn then leads to non-compliance of ventilation performance.
exactly.
Basically turn it down until I don't think I'm going to get a callback type commissioning.
And we know there is absolute evidence of that, isn't there, of people, installers saying that, if I won't get called back if it's not too noisy, but I will get called back if it's too noisy and it complies. So basically commissioning by noise level rather than airflow rate. So
yeah. But therein lies the challenge, I suppose, is that noise is in a similar place to ventilation, maybe even a little bit further behind, in that you're almost never going to be called out for noise level, not officially, on a ventilation system. So a consumer might complain about the noise level, but nobody's coming behind you and checking that the room is at 35 dBl NNAQ, whatever the thing is, or that fan is actually achieving 25 dBA at 2 meters in that space, or whatever. And that's the challenge, isn't it? Is practically in the built environment, we have some standards that we're leaning on, and we can maybe talk about whether we think they're still appropriate or not. But ultimately, if it's just not policed at all or followed up, checked in a way, then
is really interesting. Yeah, I think, and I've talked to lots of architects and contractors and house builders about this, and I always ask them, have you ever, like in your personal experience, do you have experience of noisy fans in a domestic situation that you've turned off because they're annoying? Everybody's yes, I know that, I've done that. And ask them, in your professional experience, have you ever had complaints about a building, about a house, a dwelling, where somebody has complained about the noise from the ventilation system and everybody shakes their head? They've never had that. So even to the extent that an architect told me a story about how he moved into a new housing development, and the ventilation systems were really noisy. And he said word got round about where the switch was to turn them off, and everybody turned them off. And I said, so you're an architect. Did you go back to the builder? These houses are under warranty, and say the ventilation system's too noisy. And he said, no.
Yeah.
For some reason, people don't blame the building when it's too noisy. They seem to take it on themselves. I really don't understand this. But this is really fundamental. They find their own solution, and they don't blame the building. But of course, it's the building's fault, not their fault.
So when we get to back to that kind of brass tacks level, how do we think about and regulate for noise in homes? I mean, what are the kind of hard numbers, thresholds that you can say something is either acceptable or it isn't in our buildings? Like, how is that viewed? Like, under what kind of frames? What are those numbers? And I suppose ultimately, realistically, how do you test for that in the field? How would somebody make a judgment call as to whether or not a bathroom fan in an ensuite next to your bedroom is making an acceptable noise or not? Like, how do you get there to that point?
So it's now written in England. It's in the building regulations. So approved document F has guidelines. It says 30 dBA is the limit in bedrooms, and I'd have to check, but I think it's 45 dBA in bathrooms and kitchens. So that's when you're using the extract systems from those rooms. So flat fans with a higher flow rate. Of course, these days, having a kitchen integrated with your living room is more common than having a cellular kitchen, I think. So it's also going to affect your living space.
So is there a differentiation between fans and systems running at a boost rate, so when they're having to extract at a high rate to deal with activities in those spaces, and the general background noise that those mechanical systems create when they're running all of the time? Because there you might be talking about an event noise versus a white background noise kind of problem, mightn't you?
Yes. Yeah. So there are, they are distinguished. So there is different criteria for whole dwelling ventilation rates and extract ventilation rates. I'll just have to
Interesting. Okay.
remind myself exactly what they are. I'll look them up because I've not dealing with these for a while. But I was the advisor to the the working group.
I think off the top of my head, you're right. That I think the acceptable noise levels for the background rate in bedroom areas is 30 dBA LAEQ.
That's right.
And 40 or 45 dBA.
45 in kitchens and bathrooms.
Less not in non-noise sensitive spaces.
Yes. That's right.
But I think that's the continuous background noise for those systems, isn't it? That's if you're in a bedroom at night and there's a system running in the background, that's the background level that it shouldn't go above. Yeah. Here for me is where I start to run out of road really quickly because of my lack of understanding of the nuance between how you measure ventilation. You have this threshold of 30 dB in a bedroom space, and then a bunch of letters after it, LAEQ, over 8 hours. So it's an average something, I guess. But that noise has got to travel often from another room to get to you. You have a device that you're buying or purchasing or installing that you need to judge as to whether it's too noisy or not. And how it presents its data is often in another value, might be in the sound prep power level of dBA at 2 meters. If I get that, if I'm right. But again, I'm running out of road really quickly here, but I think this is the challenge, is that we see some numbers floating around and they're not quite the same from what we see on a brochure for a product, how we might judge what that might be at a certain flow rate, and what someone might experience in a bedroom or a living room down the hall from that device, how we start to judge what good looks like. And I think that's the problem for professionals in the space, is that they go, well, I perceive this as okay, or I perceive this as too noisy, but how do I actually, where's the line in the sand? And how do I go about figuring that out?
So we can add those numbers. We can do the sums for those numbers, but I entirely agree with you. So that is not a job for the layman, if you like. So when manufacturers, as you well know, fan manufacturers usually describe the sound power of their fans by telling you what the sound level at 3 meters will be. Is the most common way. I mean, that's entirely, you could describe the sound power with the sound power in decibels rather than with the sound pressure level at 3 meters, because to calculate it at 3 meters, you have to assume you've got a point source, either with a reflecting plane or in a free field space, 3-dimensional space. And then the question is, how loud would it be 3 meters away? So you can do that calculation and work out what it would be from the sound power of the fan. The sound pressure level at 3 meters is a number that is much, much lower than the sound pressure level you get when you put that fan in a room. And the smaller the room you put that fan in, the higher the sound pressure level, because if you like, the sound has nowhere to go. If you put the same sound source in a bigger room, the sound level will be lower. But there can easily be an 18 dB difference between the sound pressure level at 3 meters in the free field compared to the sound pressure level in a small room. And it's that difference. That's where you need a professional, if you like, to do the sums and add up how loud it's going to be in a room. And that's not intuitive or anything, but because it says dB after it, everybody thinks it's the same thing. Yeah. So manufacturers give you a data sheet that says dB on it, and that number of dBs is much lower than what you think your target is, so you think it's okay. And people don't realize there's actually a sum to do between the two things.
And I've even seen sheets that express that at different frequencies as well, to make it even more complicated. I suppose there's two questions there that spring to mind. One is, should we be worried in the sense that a bit like ventilation, we know practically when we go out and measure ventilation in the built environment that you've got a higher chance than not, even in new buildings, that house is going to be underventilated. Every time we do research and studies in the field of ventilation, we see massive underperformance of those systems, like catastrophic levels. It's really quite embarrassing.
Yeah.
Are those similar kind of studies happening in the acoustic field? Are there studies that are going out and looking at 100 new builds and going, actually 40% of these homes are above the noise levels that we'd expect, or we can say that ventilation systems are too noisy in 40% of the properties we go into? I mean, is there a bank of evidence that's saying there's a problem here in the first instance? Or has that just not been done at scale properly?
It's not been done. So we put a big project proposal together about 5 years ago, put a funding bid to EPSRC in through Salford University, where they were leading it, to actually find out the scale of the problem. Because anecdotally, we hear about it all the time. But like you say, there's no broad measurement. And because measuring these things is not simple, you're talking about relatively low levels of noise. So sometimes you need to go in the evening or the night time when there's less environmental noise to actually be able to measure these levels. But of course, that is when it affects people. So the most critical time is when people are in bed going to sleep. So it's not the effect on their sleep. It's the effect on them, whether they're annoyed when they're trying to go to sleep.
Yeah.
And
the other challenge you have, I guess, is that if 75% of properties are underventilated, 75% of the fans you're measuring probably aren't running at the speed they should be anyway. So it's a bit like air quality. We see so many studies going in to look at air quality outcomes in buildings, and mostly it's just a study on crappy ventilation, or the outcomes of crappy ventilation. And similarly with acoustics, there's no point going out and measuring 10,000 homes if 7,500 of them are underventilated and the fans aren't running at the speed they should be. We've kind of got to get to a point where what you're measuring is working at the performance levels it should be to determine whether or not those sound levels are acceptable at that point. We
don't need, from an acoustic point of view, we don't need the ventilation system to be working. We just need to know that it's creating some noise and correlate that with people's response. So what levels of noise can people actually tolerate is what we need to know. And we don't know that. So we don't really know how to characterize noise. We know that dBA, which is our most common way of measuring sound and noise, is not a very good characterization for low levels of sound that might have characteristics in it. If it's got any tonal content, or characteristics which make it particularly that draw your attention to it, it's going to be much more annoying. But that wouldn't show up when you measure the A-weighted sound level. It could have more low frequency sound in it, which again wouldn't show up, wouldn't change the A-weighted sound level, but might be much more annoying.
Can you characterize that the quality of the sound and its impact on annoyance? I mean, there's a sound of my mother-in-law joke in there somewhere, but there's got to be because like you say, you could have the same sound power output, but one noise could be extremely annoying and another noise might just disappear into the background. You might barely be able to hear it.
There's a lot of emerging science on this, or psychoacoustics it's called, and there's different metrics being developed. And this science has been, as far as I can tell, developed most by the automotive industry, because that's where people pay for the most money for sounds they like or don't like.
Interesting.
So people often talk about the sound of a car door closing. They spend a lot of money on getting that sound right. And there've been debates about how much, whether it's, modern cars play back sound through the loudspeakers, engine sound into the cabin, to give the occupants a sense of power. So when you put it in sport mode, it doesn't just change the engine; it changes how much sound it gives you back in the in the cockpit, so that you feel like you're getting more power out of it. And so that's the area where the most, as far as I can tell, the most research has been done to correlate sounds with perception. And so because of that, a lot of the metrics are connected with engine speed or speed of something. So they're very interested in whether you can hear tones in things and things like that. Whereas in general environmental sound, of course, we don't have those sorts of characteristics of sound at all. But we've got these indicators like loudness, tonality, sharpness, roughness, that describe characteristics of the sound, and we're starting to put numbers on them. But they're really ways of describing with numbers what you can hear.
Yeah.
So our best description is still qualitative. So you answered your question, can we measure it with a meter? Not as consistently as we can listen to it and say what we think about it.
Interesting.
So
and it's
very difficult because of that. So
it's analogous in a way to me to this likelihood of discomfort metric we see in air quality, and how you translate that to an individual case. So a lot of the standards we have in ventilation for some of the air quality metrics, or certainly the ventilation performance metrics that we have, are born out of this likelihood of discomfort, where you stick 100 people in a space or get 100 people to sniff something, and as long as 80% of them or more don't express dissatisfaction, you can say that that's an acceptable air quality or flow of air. And that's where we get all of our half an air changes an hour from, and all of these numbers stem from that. But you kind of get there through numbers. It's very difficult to translate that down to an individual. You can't, express satisfaction at an individual home level because it's so individual to the person.
Yeah.
So is that kind of where acoustics is at the moment, in that it's hard for us to demonstrate on a device and on a dial to say that this has hit a red line or crossed a threshold of a particular value. We're relying on the qualitative nature of that sound still from because one person's acceptable level might not be somebody else's. How do you navigate that in the built environment?
I don't think in this particular situation of people in their bedrooms at night trying to get to sleep, that research hasn't been done to test how many people will tolerate certain sounds and how can we characterize them better to understand that. So a little bit of it has been done with in characterizing the sound in terms of dBA. And so we know if you make it quiet enough that you can barely, you can't perceive it, where at a kind of sound level where you would, if you were trying to hear it, you would kind of stop breathing, because even the sound of you'd have to keep really still. At those sorts of levels, of course, it's very unlikely to be a problem. And so we know that some hotel brands have standards more like that for their hotel bedrooms. And these aren't 4-star hotels. These are 3-star hotels, where they know sound is really important to people because they give them their money back if they don't get a good night's sleep. So they've got the most sophisticated quality system for dealing with people's noise problems, and they've updated their design to respond, the design specification to give people what they want for a good night's sleep. And so their criteria are lower, much lower than building regulations or many 4-star hotel brands, for example.
While I have you, I just want to briefly talk to you about Ultra Protect, a partner of this podcast. They're not here by accident. Like the podcast, they are passionate about driving changes in our indoor environment and are an all-round great company to deal with. They have years of experience in the industry and a team of people I have leaned on many an occasion for advice and insight. From continuously tracking air quality to specific sampling, they analyze and provide actionable insights for the built environment. Specializing in dust management, they provide amazing products and services that minimize risk and improve environments from construction sites to offices to manufacturing settings, through to solutions around ventilation aimed at improving the environment in the long term. It's a company well worth checking out. There are links in the show notes and on Air Quality Matters sites, and of course at Ultra Protect UK. Now, back to the podcast. Well, what are you getting down to from a kind of a dB, LAEQ kind of level? Are you down then at 20, 25 kind of numbers
so
in
low
the space?
20s.
Low 20s.
Yeah.
Exactly. Now, I keep throwing out these numbers. I mean, again, sound is on a logarithmic scale, if I'm correct. Yeah. So like just increased, adding another 10 isn't just a 10% increase. Like this is a scale that is hard to imagine. But also still, I think we can probably all just about imagine what something that's so quiet, when you're trying to listen to it, you find yourself holding your breath to try and hear it, or putting your ear up, trying to catch it as a sound. That's probably not a bad baseline to enter on, actually, I suppose, is because that's like a baseline. If it's at a point where I can barely hear it, I think everybody can have that as a baseline. It's the stuff in the grey middle that's difficult, I guess. You know, what is 35 dBA LAEQ in practical terms for people? That might be harder for somebody to perceive than something that just you can't hear or you can barely hear.
Yeah. Yes. Yeah. Yeah. So 35 would be like, as you would consider it to be quiet, totally quiet in the daytime.
Yeah.
Certainly that would be, you would start to notice all the small sounds.
Yeah.
Or smaller sounds.
And I've had personal experience to that when we first built this home where I live now. Is when we first moved in, we installed an MVHR system, and it was at that kind of noise level that in the daytime you couldn't hear it, but at nighttime you could just.
Okay. Yeah.
But it was a consistent white noise that after about 6 months, our brains had zeroed it out. We couldn't hear it anymore. So and that's actually another phenomenon, isn't it? Where you get a steady state kind of background white noise, your brain has this ability to unhear it after a while. So we had this conversation regularly where we're going, you can't detect whether the ventilation is on or not by hearing it, because your brain has almost cancelled it in a strange way, and yet somebody comes and stays with you and goes, oh, is that a ventilation system I can hear? And you're like going, oh, yeah, I suppose it is.
Yeah. So I think what you're talking about there is habituation, how we become habituated to sounds. And that works in different ways. One, like you're talking about there, where it's there. And even if you think about it, you're not sure if you can hear it or not.
Yeah.
But people talk about that, people who live near train lines get used to the train passes. And obviously that's very intermittent, not continuous.
Wow.
But people don't notice the trains going past. It still has an effect. It might still have an effect on their health that can be measured, but it doesn't register in their minds as an event, because cognitively they've understood that's something I don't need to think about.
Yeah.
And where our brains are really clever, because our brains are so good at recognizing patterns in sound. And we know that feeling of being in the woods, if you like, and the birds stop singing. So we notice when a sound stops, even if we didn't notice it when it was happening. You weren't listening to the birds singing, but you've just realized there's an eerie feeling because it's just gone quiet. And that gives you a sense of danger.
Yeah. The hairs stood up on the back of my arm there when you said that. Like, that's an instinct thing. Like, I think everybody's experienced that kind of that what's going on sensation where there's quiet. Gone quiet. Yeah, it's not good.
And it's used in films for that effect.
Yeah, for sure. And I think they understand that, particularly in very highly acoustically treated spaces as well, that actually you introduce some white noise or background noise because the brain is actually more comfortable with a buzz in the background, something. If a space is too quiet, it can be the opposite as well, can't it?
I don't know if you're talking about offices there.
Yeah, offices. Yeah. I'm thinking of my kind of AP struggles trying to get through the acoustic thing of actually introducing speakers that provide some noise in the background.
Yeah. So this is a really interesting subject because it's incredibly culturally polarized.
Is it? Okay.
So in America, they won't build open plan offices without sound masking systems. So they will always put sound masking in to make sure the background sound never gets too quiet. And what that does, it means you can't hear speech from as many people. It becomes less distinct. And the most annoying thing in open plan offices is speech that you can understand. So as the background sound level goes up, then people's speech, people that might be 4 meters away, you can no longer understand what they're saying if they're talking at a normal level. You're still going to be able to hear somebody next to you. You can't make it loud enough. You can technically make it loud enough so that you can't understand somebody at 2 meters. You know what it's like in a busy bar. You have to shout in somebody's ear to hear. So that you can think of that as a really high level of masking sound. But obviously you can't have that in an office because if the background sound level itself gets too high, it is really annoying itself. So there's interesting debates about whether there's a level that's high enough to be useful, but not too high to be annoying. People have that debate. But I think the more interesting, or a really interesting debate anyway, is this cultural attitude to sound masking systems. So America, they wouldn't build an open plan office without them. In lots of continental European countries, where they've tried them, they've hated them, ripped them out, turned them off, said, we'll never do that. And they have a culture, like especially in Scandinavian countries, for example, of open plan offices are quiet places. They're not places you talk to each other, have phone calls, do things like that. They're places where you go to work quietly. And people have told me about offices where you've even got a corridor outside private offices where the sign on the door says, please don't talk in this corridor. So not even in the same space as other people, but outside the door from them. And so in those places, they expect the sound level to be much lower than the level of you would use for sound masking. And they don't need sound masking because nobody's talking.
Interesting.
So the way people behave and expectations are kind of the most important thing about open plan offices. And then if you do have an office where you are going to have people talking and you don't want to disturb too many people, then it can definitely help to have sound masking.
Interesting. And is that a phenomena that can be applied across acoustics similarly with ventilation and air quality outcomes, that there are huge regional differences both in culture and expectations and outcomes? When you're talking to acousticians from South America or India or Asia, you sometimes just talking at complete cross purposes because there's such big cultural differences in approaches to and tolerances of sound and things like that?
Yes, I think we don't, if you like, celebrate these differences enough. But we know, I hear things like a particular manufacturer of vacuum products, for example, that sells globally. They have a choice in the design of their products about whether they make them more powerful, quieter, or smaller. They can't achieve all three. And in Japan, people are much more sound sensitive, and they make them quieter at the expense of the power, because it's more important to people that they're quiet. And other countries have reputations, if you like, national characterization of putting more importance on products, the sound of products being quieter. American products characterized often as being louder. American cars, for example, you can see this in cars. You can do a national characterization of different the sounds of different countries' cars. They sound quite different. And it's not by chance. The manufacturers design the sound of their cars. They're not, but they are very much in the country in which they're designing those sounds.
Interesting. Yeah. So I as I always do, we went massively off topic there. But so like as of today, for practitioners, let's keep it simple and say, I say simple and keep it residential, but let's just say residential. Yeah. We have these numbers that appear in standards, same in Ireland and Scotland and the UK and other parts of the world, for sound levels in spaces. Is your sense that those numbers are the right numbers to be using, as in the how we characterize sound, and are they roughly at the right levels? I mean, a bit like ventilation and air quality. I keep kind of making it analogous to this. A lot of the problems we face with air quality in the built environment would be solved if we just hit the numbers that were in the standards in the first place.
Okay.
Like there's not anything majorly wrong with a lot of the standards we have for ventilation as they are. The bigger challenge is actually getting the industry to hit those numbers, implement it. Yeah. Is it similar for you? Are you uncomfortable with how stuff is measured or the kind of thresholds that are being set? Or do you think it's roughly where it needs to be?
Well, there's still strong cultural elements in that, because the standards in America, for example, for mechanical services noise, and in the WELL standard, you get maximum credits for mechanical services noise levels that would fail to meet building regulations in Sweden. So from an American's point of view, the best, going beyond good practice in Sweden isn't good enough for just to meet building regulations, never mind improving on it. So Americans, we would characterize as they like to hear the building services to know it's working. And I think we all have that experience. Or, if you go into a hotel and it's got a comfort cooling system, if you put it on high, you would expect to hear it. And you would expect to be able to turn it off to go to sleep. You wouldn't necessarily expect to sleep with it on high. But that's just entirely driven, if you like, by what people will culturally tolerate. And I've heard that in Japan, they make it quiet at whatever setting you put it at, which you can do, of course. That's just an engineering solution to a problem. It's just whether you need to. And there, people insist that it's quiet at whatever level they're running it at. So again, different tolerance. So I think the numbers, coming back to your actual question, the numbers we have for mechanical services noise at the minute, I think, are too high, because they're basically based on environmental sound levels. But people respond very differently to noise from building services compared to the way they respond to environmental sound. So that research that I was talking about hasn't really been done. And we're not quite bold enough in this country to pick up bits of research from other countries and say, we really should be making mechanical services quieter. Because Passive House has a standard of 25 dBA. Our building regulations is 30.
30 and there's quite a big difference between 25 and 30, as we said. And in your guidance for acoustics and ventilation, which you did a few years ago, you suggest that the target should be 25. And there's a good reason for that, I guess.
Yeah, exactly. 26, I think, was the number. We said you could either adopt 30 or 26 is better.
And so in general, we're using the right things to measure, but we think they might be a little bit too high. We could improve it. Practically, where do we need to get to satisfy ourselves that that's being achieved? Is this something that could be within the remit or the purview of ventilation people, or do we need an entire industry of acousticians who are a bit like we're fighting very hard at the moment for third-party validation of ventilation systems in the UK. We have it in Ireland. France has adopted it. Many European countries have that. This recognition that you need an independent party to check that you're achieving the flow rates that were set out within standards. Do we need to get to the same place with acoustics, that somebody is coming into a building at completion and saying this building is doing what it should do from a sound perspective?
Well, that would be, I think so, because contractors, housing developers, builders absolutely know when something's going to be tested at the end, they give it attention and make sure they do it right. and if it becomes a risk to them, and so they do the right thing, they manage that risk by making sure they do it right. And if it's not going to be checked at the end, they don't really care. They give it much less attention, of course. So
now there's some industry there, isn't there? I mean, so you will get tests on things like noise transfer between floors or between party walls, particularly in larger developments.
Exactly. So they're the only tests we do at the minute are sound insulation tests between dwellings, from one dwelling to another, through walls and through floors, where there's a dwelling is in another part or has another part of the building. So it could be blocks of flats, or it could be other uses, or And we don't test all of them. We just do sample testing, so about 1 in 10. So there's no reason why we couldn't do sample testing of noise from ventilation systems. That would be the sensible thing to do.
That's what I was going to ask. So there's the bones of an industry there ready to go potentially that could step up and fill that void and just do other tests.
Yeah.
The challenge, I guess, is that you're trying to measure sound at a completion, which is likely to be still construction phase within a development at a time of day that's not optimum. How would that practically work, do you think, where you're trying to measure very low levels of noise in noisy environment? I know the ventilation and air tightness people will be screaming at the radio or whatever it is they're listening to their podcast through, going, like, we have a nightmare just trying to do the ventilation test with painters coming in and out and doors being slammed and beeps of reversing lifters outside the building.
Exactly.
It'd be a nightmare.
The classic thing is, by the time they get us to do the sound insulation tests inside, what they're doing outside is trying to tarmac do the groundworks to get the pavement the tarmac down. So it's the big heavy machines they got outside going back and forth. So that can be difficult. That could be a real practical challenge. But I think if something, we would do it on an evening, that's fine. We just do it out of hours. And
actually, it's a really good point. Yeah, sites shut down. So it's a great. You could go in a bit like thermography is better at certain times of year. Sound testing will be better at certain times of the day. It could potentially be possible.
Yeah, exactly. It's just logistical, but that's no problem really.
How visible is sound? So one of the transformative impacts we've seen in the air quality community is our ability to see the air like we've never been able to see it before. The evolution of low-cost sensors into the built environment, that kind of thing. Because there's nothing better than the ongoing performance metrics of spaces to truly understand, because we build buildings for people, and ultimately it doesn't matter how it performs at handover. What we're interested in is how it performs in use. And the evolution of low-cost sensors in the built environment has been transformative to air quality. Could we get to a similar space with sound meters and things in the built environment to understand from a metrics perspective?
That's interesting. Yes, I suppose from my perception, I see the reason for all these low-cost air quality sensors is because air quality has been a political subject. Because we've got laws about air quality outside, and it's been bounced around and used a bit as a political football, and that's put lots more people's attention on it. So from my perspective, that's why people have all these sensors, because their interest has already been piqued, if you like, by what's going on in the media. I don't know.
Interesting.
I think that. So
I think
that's where it starts, if you like, in terms of people say, there's this environmental phenomenon that you didn't realise was causing you harm in air quality, because that's the double trouble you have in air quality, is that people might be subject to really poor air quality and don't even realise. Whereas noise, you usually know about it.
Do you? So is it if sound is a problem, people will know about it? It's that simple? Or can acoustics be a silent killer in the same way that air quality can?
Yeah, without no pun there, obviously.
Yeah, yeah,
um, um, I guess for many people living in adverse sound environments, sound isn't their number one priority or problem. And so from that point of view, it's not the thing they're most worried about. They might be most worried about keeping their home warm, or, they might turn the ventilation system off because they think it's costing them money, or they don't want to open the window because of losing heat.
yeah.
And so noise is often a kind of secondary problem in that type of situation, if you like. So it might be having an effect on them, but it might not be the thing they're most worried about.
I think that's true of so much of indoor environmental quality, though, and particularly people that work in the social housing space, will often comment that being able to be concerned about air quality is a luxury if you can't afford to put food on the table, or you're worried about how to heat your home. That these things are down the list for a lot of people. So it becomes silent because it's just not a priority, and it's not that it's just not a priority this week. It's just it's never going to become a priority. There will always be some other things that are more important for people. So in that sense, we've seen that with things like environmental monitoring in social housing, that the value of these devices is that they create tools to help landlords and tenants get better outcomes that they wouldn't be able to get otherwise. So while it might not be a concern for a tenant, that their concern is being able to heat and put food on the table, that environmental sensor is being able to visualize for the landlord heating patterns in that dwelling that suggest that person's in fuel poverty. So it enables them to provide and intervene earlier, and everybody is better for the result of it, or that a property has become void and is at risk of deteriorating over time. And I could well imagine sound being very similar, that you could pick up stressors or things that are going to impact people or contribute to this overall understanding of the built environment that could have some really useful impacts and tools that may not be a priority in that moment for a tenant or a landlord, but could help form the picture of the performance of spaces. Like if you're struggling, like if you've got problems with antisocial behavior, or you've got problems with fuel poverty, you may well be suffering enormous stress from background noise in your built environment. But it just never makes it into your top 5 things to worry about that week, to deal with, or ring up and ask the question, or complain about, or try and act on. It strikes me that sensing could provide some interesting insight in that way.
The slight difference with noise is you know about the exposure of a property to environmental sound is basically fixed and constant. So you don't need sensors to give you that information. So then the only information, if you like, that's relevant is about the noise from the ventilation system. And again, that would be difficult to detect with sensors. And people might not agree on what a level, it could be 30 dBA, and we know that actually 30 dBA is probably too noisy if it's at 30 dBA for most people. Like way more than half people would find that annoying. But
I know
struggle to do anything about it.
So. I know with data from noise that they can do some amazing things with, for example, the quality and shape of sound that's emitted from devices. Over time, machine learning, understanding that sound type is characteristic of a failure of a bearing, or a deterioration of a fan, or we see an overrun of fans in bathrooms of 15 minutes, but that fan happens to only be overrunning for 5 minutes. We can detect that sound wave, there's a sound is an incredibly rich source of information about the environment if you're prepared to have microphones basically all over your building, right? And so there's a massive GDPR thing there, obviously. We'll get onto that, but from a potential perspective, it's almost limitless, I'd imagine. Like truly listening to noise in a space could tell you an unreal amount of information about that building.
I'm sure that's true. I mean, that what you were talking about there first, the condition monitoring of mechanical equipment has been going on a long time in industry of using those signals to predict when they need to take preventative maintenance. But what's happened more recently with the advent of low-cost sensors and things is networks of sensors across cities. So people are starting to map the sounds in the urban environment and put it together with emergency call outs or things. Could you predict when somebody's going to dial 999? And things like that. I'm sure there's lots of privacy issues with those sorts of measurements. But
I've had this conversation with you before. I remember years ago about trying to understand truly whether a dBA sensor in an environmental sensor is actually a microphone or not. Like a something that's measuring sound pressure in a device. I remember ringing you up one day about going, look, can you have something that measures sound pressure in a device that isn't actually a microphone? Like, how does that work?
So I think you mean not recording the sound.
Not recording the sound, yeah. Or a possibility of recording the sound even. Can it just...
I think if you can detect changes in sound pressure, in the sound pressure waves, then you have the ability to record sound, potentially. Yeah. So you can't have the detection without the possibility of recording the sound, but you can absolutely have devices that can measure the sound pressure but not record the sound, just the sound, just the level of the sound pressure as a number. So
and is that
do that?
I don't know if you know the hardware, but is that a software fix, or is that a fundamental hardware problem that can you have a device that doesn't record but could be hacked or bugged or something and turn to record something? So the moment you have something that measures sound waves, in theory, I guess you can hear what's going on that space if you can tap into what it's saying.
I don't think it's quite as simple as that, because you have to record masses more data to record the sound, to measure the sound level.
Fair enough.
So you couldn't really hack a device which is only capable of measuring the sound and turn it into a recording device without physically intervening with it, with all of it, the whole device. So
apologies, folks, for the rabbit hole. It's just the way my brain works. But I suppose to get back on topic a little bit. So let's translate this into the real world then. How is acoustics manifesting for you as acousticians in the built environment when it comes to something like, let's say, complaints? So if people are saying, I think this ventilation system is too noisy, what does the process actually look like to determine whether or not it is or not? I mean, like from the phone call coming, so somebody rings up your office, Jack, and says, look, I've got a building. We're in a bit of an argument with the landlord. We've complained for 6 months. We're pretty sure this system is well above the noise levels that it should be. I've got people that are threatening to leave the business. Can you come in and advise us? Like, what does it look like to actually come in and determine whether something is good or not from a sound perspective?
Well, I suppose maybe the first thing is to say this so rarely happens. I'm trying to think of the last time somebody actually complained about the sound from the mechanical services, because what happens in offices is exactly the same as what happens in homes, is that if you say it's too loud, if we're doing commissioning measurements in a place where they're required to have commissioning measurements because they want credits for doing that for BREEAM or something, and we say it's too noisy, their initial response is to turn the fan down until they get a pass. So that's the most common thing. I'm trying to think if we ever get complaints from people about saying it's too noisy. They just turn it down.
So maybe that's the wrong approach then. So okay, let's think about practically what it means to me as a ventilation installer, designer installer in the residential settings, that I know I've got this target of 35 dBL, LA, and EQ. I still need to ask you what all those letters mean, but I've got a target of 35. I'm looking at fan brochures that say something completely different. How do I practically navigate that world? How do I specify and install a ventilation system and be comfortable that I've made the right choices? Like, what does that look like?
Yeah. So I think what you're actually talking about there is design. It's mechanical services design. So it's the acoustic design of the mechanical system. And that's not a simple or trivial job, unfortunately. So if you're trying to do this as a self-builder, then the people who most commonly do these calculations actually are the companies that supply the systems. So mechanical or acoustic engineers might do this or will do this on a commercial system. But usually the specification of the attenuators on a commercial system is done by the mechanical services installer, who will give all the information to the attenuator company and say, what attenuators do I need? It's the attenuator company that actually designs them.
But see, the trouble is, it probably 3/4 of the residential sector is not designing ventilation. Yeah. It's specifying product that it's done a deal with a manufacturer on for a big residential development, or it's the fan that you can get from your local plumbing supplier. It just happens to be the one that they do, or it's the one that you've got used to using, whatever. And this is the problem. This is so technical guidance documents. And I was speaking to Peter Ranking about this on the podcast. It is this challenge that technical guidance documents are just that. They're guidance documents. They're there to give you, in normal circumstances, in normal use, this is what gives you the best chance of possible of prima facie compliance with standards, with regulations. And that's fine, but we start to use them as design guides because the only thing we've got to lean on. So I'm there as your Joe Bloggs ventilation installer, whether it's MVHR or not, and I'm just throwing ventilation systems in. I'm struggling as it is to be good enough to hit the flow rates that I want. What does someone like that do to start being comfortable or confident that they're making the right acoustic decisions on projects? Can they have a sound level meter in their toolbox and do some kind of cursory checks, like benchmark sanity checks when they finish? How do they realistically translate a 25 dBA value on a fan table on a brochure to hitting a 35 dBA LNAQ over 8 hour target in a bedroom? Like, how do we navigate this space, Jack? Like, practically?
I mean, I think maybe what you're asking me there is somebody who's not a designer do the design, and I think that's a really difficult question because you can't. There's no shortcut to doing the detail of the design. But people in that situation who have that experience of doing it regularly, and as you say, they could buy a cheap sound level meter, but I don't think it's necessarily going to give them the right number. I mean, you can get obviously an app for your phone that will tell you a dB number, but it won't work very well for low level of sounds. So I think they're probably best off in that situation having a really critical listen, if you like, to the system once they've installed it in quiet conditions. And trying to benchmark that somehow about how they would feel about that. Does that sound okay to them? It's obviously that it's becoming entirely subjective, but without becoming a designer, there's no shortcut to doing the design.
Yeah. And you as a designer, as an acoustician looking at a design, you can have a look at a product brochure, a set of plans, and
Exactly.
a standard in the regulations. You can do some calculations and have an idea whether or not that setup is going to comply or not.
Exactly.
Is the information that you need to do that available from manufacturers easily at a domestic level? Because one of the problems we have in ventilation, even from an air quality perspective or an airflow perspective, is often even the fan curves that we're looking for aren't, because a lot of the information is presented by the marketing departments.
Yeah.
So what you get is the best possible case presented in the most glossy way possible. Very often you don't get to see the information you need to actually do a calculation realistically. Are you in a similar boat with acoustics often, that somebody goes...
The difficulty in acoustics is that you don't know where the fan's going to be operating, because there will again be a design point. If it has been designed and the manufacturer does have information about how much sound a fan emits at different operating points, so a different pressure over it and different flow rates. Let's say they do have that information, and then they've calculated what the pressure difference across the fan will be based on this installed system. So if that all exists and it's accurate, if that's true, then we could usually calculate the sound level. But again,
you'd need to know where the fan is in the room. You'd need to know what the build-up is around that fan.
Well, I'm thinking about a fan, an MVHR system. I'm thinking about here where the noise is going to go through ducts.
Okay,
the number of bends and the length of straight ducts, and
most properties aren't MVHR. So in those circumstances, we've got noise emitters in rooms that are either next to a noise sensitive room or down the hallway somewhere. How do you begin to figure out what the outcomes are going to be in those circumstances? I can understand if you've got a system and you understand noise loss through a ductwork and you have an emitter in a bedroom that's going to either create, in addition to whatever background noise there is, over 35 dBA, right? I can understand how you might get to there.
Yeah.
But for all the other types of buildings, decentralized MEV, PIV systems, natural ventilation with intermittent fans, all these different types of systems where you've got fans in bathrooms and kitchens and utilities and things like that creating noise. How do we is it even possible to determine what an outcome's going to be in a bedroom? Like, if you're looking at...
if the fan's in the bathroom, and the bathroom's, even if it's an ensuite, and you've got a door in it, it's not easy to calculate what the sound level in the bedroom might be. And at the minute, there's no actual standards for that. The only standard in the building regulations is for noise levels in the habitable spaces, so the living rooms and bedrooms with whole dwelling ventilation, that's 30 dBA. And then the sound level in bathrooms and kitchens where you have extract ventilation, and that's 45 dBA. So they're the only levels. It doesn't ask you what's the sound level in a bedroom when that fan is operating in the bathroom. That doesn't fall under the regulations.
So have you or anybody that ever been asked to look at a development of houses, say, that are at planning stage and say, are we on the right tracks acoustically from the ventilation perspective here? I've got DMEV going in. Here's the product. Here's the plans. Is this gonna?
Nobody asks us if the noise from the domestic fans will comply with what it says in approved document F part 1.
And I think therein lies the problem, right? We've got a chasm between an environmental risk we know has a significant burden of disease on the population. We've got products that we know emit noise in the built environment and are one of the most common things to be turned off or to impact the behavior of their use. in the built environment, and this massive void in the middle where nobody's even asking the fundamental questions, even at scale where you've got 380 archetype A's. You only have to do the design once, right, to get this right. That question's just not being asked. Not being asked. And therein lies the problem, I guess. Yeah.
As you said, I mean, this is part of what I said when I said these systems don't get designed, specified, procured, and so on. In an appropriate way. This is the design question.
And I'm a consultant. I'm trying, right? So I would advise people regularly on strategies for ventilation in the built environment. And I will say I've lent actually on your 25 or 26 dBA. I said, look, the target is this actually. Like if you can target that, but it needs to be below this. But that's kind of where I run out of road on it, because I don't really have a practical way of judging whether that's what they've got ultimately.
Okay.
And so you can advise. It's fairly straightforward to say that on a bit of paper, in a paragraph, in a spec.
Yeah.
But backing that up, ultimately, we're kind of back to, like you say, that anecdotal thing of saying, well, this ultimately comes down to common sense. If we design the system with enough capacity that it's not screeching at the top of its voice just to hit what it needs to, and when we commission it, we use common sense to say, I think that's too noisy. Is that kind of where we are?
Well, that actually makes me uncomfortable, that approach, which has been described as saying that fans shouldn't be designed to be used at whatever % of their capacity, because I think that's a secondary way of trying to control the noise, if that's what it is, because you should just let the designer control the fan however it needs to be and specify that, and it's their job to control the noise to specified levels. Wherever the fan's operating, that's up to the system designer. It's not. Yeah. So I think that's a kind of, and I think when you start having regulations like that, you then get perverse adverse outcomes, because you've got construction constraints, if you like, rather than just performance criteria. Really, we should just have performance criteria and leave the design up to the designer.
I agree completely.
If it happens. So it's a kind of backstop protection, isn't it?
But it has other backstops. So the capacity one was something that was introduced in Ireland. So in Ireland, you calculate the general ventilation rate of a property, and then whatever system has to go in has to have a minimum capacity of at least 25% more than that.
Okay.
And the reason that was introduced was severalfold. One was with MVHR. What you don't want is people specifying a product that's at its limit at the general ventilation rate. You want some capacity, and 25% isn't enough actually for MVHR. You want it more than that, but it's a start. But equally, you can have somebody having a bad Friday who doesn't install very well. And if you don't have a fan in there with a bit of extra gas in the tank, you've got no aftermarket ability to get a little bit more out of it. Or your assumption for the property is that it's going to be populated X and it ends up being populated Y. If you haven't, it's like all engineering, you're building some redundancy, some capacity for unknowns. But that's a design decision. Like, you're making a calculated decision there. You're not saying, I want this fan running at 50% because that's the tolerable noise level kind of thing.
I think you have to be careful though, because there is a cost to designing in safety factors and redundancy. And we've just seen one of those constraints be removed, and it took quite a long time and effort to do this. So for air source heat pumps, there were permitted development rights that in England said you can't install it at within 1 metre of the boundary of your property. And this was a kind of backstop to prevent the noise impact on your neighbour. But actually, there's lots of situations when the noise impact on your neighbour will be less if you have your air source heat pump less than 1 metre, because it'll be tucked behind a barrier and it'll be more shielded from your neighbour. So I think you have to be really careful with these types of secondary constraints, if you like, to try and get the outcome that you think you want. because they don't always help, and they can. I prefer performance criteria that are going to be used, and maybe in that example of airflow, and you give me some examples there of why you might need some more capacity in the system, and one of them being it wasn't designed right. Well, if there was
if it was designed right, it wouldn't be the problem.
So you shouldn't have, from my point of view, you shouldn't have the wrong design with the specification, because someone's going to design it wrong. You're only going to get half of what the specification is. Just meet the spec. It's like.
Yeah, it's a really interesting point. I mean, one of the things that I say within my documents when I'm advising people is to say, look, the design characteristics of this ventilation system is X, and it needs to operate within these sound levels at this level, but it needs the capacity, if we choose it to do Y, because we made this may be a house under a specific pressure because it's a social house, it's over occupied. We want it to be able to do more than the general ventilation rate, but I expect it to operate at the same acoustic levels or within those acoustic levels at that capacity as well.
There you go.
Right. So it kind of answering your question, is it doesn't matter what it runs at. The threshold for noise is the threshold for noise. If you're only just creeping under the threshold at the design rate, the general ventilation rate, you now don't have any capacity to turn that system up, because it's now going to become a noise nuisance. Yeah. It's that kind of approach that the challenge I have, and I'll be quite frank with you, is that it's easy for me to say those numbers, much harder for me to hold people accountable to achieving them. And that's the difficulty. And I don't know what that looks like.
I would say the easiest way to solve that problem is say this will be tested on completion. And then the contractor, when they see that, when they know it's going to be tested, they will go away and make sure it meets the spec. So you don't have to design it. You can pass that on. And when a contractor knows it's going to be tested, they'll give it far more attention, and they'll make sure it works. They're good at doing whatever outcomes are needed. There's a cost to it, and if that's what you want, that's what they'll do.
Yeah, you're echoing a position I'm holding much more frequently these days, and that's this bookend of an idea that you say you're very clear about the design intent, and you have a QA process to check that you got what was designed. The stuff in the middle, that's for the supply chain to figure out. If you've been clear about what you wanted, and you've been clear that you're going to check that you got what you wanted, the building industry is very good at getting there, but it needs to know where it's starting from, and it needs to know that it's going to be checked. And we've seen that in all sorts of elements of the built environment, from scaffolding safety and PPE to structural safety and all sorts of things. Like, when the industry knows what's needed, and they know that they're going to be checked, it's a very reaching for the word, but it's quite military-esque construction. It's if anybody that's ever not been in a site meetings don't dwell on the politics and the whataboutism of stuff. It's a solutions-orientated environment. Construction just needs to get it done as efficiently as possible, and everything's set up in construction to do that. Yeah. So once they know what's expected and they know that they're going to be checked, it's unbelievable how quickly construction moves.
Yeah. And the converse of that is they're always trying to reduce costs. That's their job. Yeah. And so if they can get away with not doing things, that's absolutely what they'll do. And you can't blame them for that. That's contractors' jobs, is to meet the requirements of the contract, manage risk. And so my architect friend, Mark Siddle, who I co-wrote that paper with, says that occupants are the crash test dummies of the construction industry, because every building's a prototype. Yeah,
absolutely. And Tim Sharp, that was on the podcast there recently, said that construction is one of the few manufacturing processes where we don't have these feedback loops like we have in other systems. We create products, but it's very conservative. The way we do it is that by moving really, really slowly and through slow iteration. And one of the challenges we have in the built environment at the moment is technology is moving faster than construction has historically moved. So products and materials and information is appearing at a far faster rate than the skills and trades and risk management traditionally moves. So we're in this weird world that we've got all sorts of products and abilities and potential to do stuff, and an industry that just is not set up to innovate and adapt and measure success well enough. And that's why we get these performance gaps.
I think there's at least two types of performance gaps, aren't there? Because one is the physical measurements. We do so few physical measurements on completed buildings. But how much post-occupancy evaluation we do about whether people can actually use the systems that have been designed. And as you say, like, technology is changing so fast, but our ability to use buildings, which has strong social roots and cultural roots, and how we expect to use buildings and how people do actually use buildings, I think plays a really strong part in this, because we need to design buildings that are intuitive for people to use. And we've seen these problems when it comes to energy performance design, in that buildings have been designed in ways which people can't actually use them. And I strongly suspect, but I don't actually have any evidence for this, but when some people complain about air source heat pumps not providing sufficient heat for their dwellings, it's because they're trying to use them intermittently in the same way that people use gas boilers. But the peak heat delivery from an air source heat pump is usually much less. You need to leave it running constantly, which people aren't always used to doing. So this is just what I suspect. I don't have any actual evidence for that. But
I think there's a lot of evidence. I think there's more and more evidence that's kind of backing that up. Yeah, we see that in hot water use. You know, people that have had, particularly in retrofit, where people have come from gas networks where they've had combination boilers and have got use over the years to endless amounts of instantaneous hot water, now have to live with a hot water cylinder for the first time in their life and experience the joy of running out of hot water when your teenage daughter takes a shower. Like, that's not a new experience or a problem if you've grown up with a hot water cylinder, right? But it is a perception and a problem if you haven't. And so there's a lot of revolt to those types of systems just purely out of historical use of those spaces or traditions,
And this takes much longer to change, potentially. And I mean, and we're both familiar with Tim Sharp's work, of course, that showed that actually trickle vents are a highly misused part of a ventilation system, in that most people don't understand what they're for or how to use them. Very few people actually operate them in the way in which they're designed to be used.
That's a really good point, and thank you for bringing up trickle vents, because I made a note, and as I suspected, we'll run out of time really fast, Jack, as we always do in our conversations. But one of the things we haven't talked about is the point source of noise from an ingress perspective to outside. And one of the things I don't think we're paying enough attention on is the acoustic attenuation of ventilation products, particularly trickle vents and wall vents and so on. And one of the areas that I'm seeing this manifest very regularly is retrofit, where we're effectively changing the acoustic characteristics of the fabric by improving glazing and insulation in walls. And then we insist on a hole being put in that fabric for the provision of ventilation. And that hole now becomes a point source of noise, where it wasn't seen as one before necessarily. And becomes a source of annoyance, and then therefore gets shut and closed. So that you can acoustically treat trickle vents and wall vents, but I don't see that being specified enough. And that's not a hard calculation to make. There's some fairly good, solid acoustic attenuation numbers for products that can be tested, but we don't see that being specified regularly enough in the built environment.
So we would only specify, we only do that work to specify those performances when there is a planning application. So I don't know if it was retrofit work, whether that would invoke planning, but probably not in most situations. And it's because it's not in the building regulations. There's no other standards. There's no performance standards to be achieved. So one of
the most common reasons vents get shut. If you've got because of the noise, like if you've got fabulous triple glaze or double glaze windows installed in your retrofit and somebody's slapped on 100 mil of external insulation on your walls, your fabric has become pretty soundproof overnight. And now you have a 4-inch hole in the corner of your living room, letting very valuable air in. It's there for a reason.
Yeah,
that's where all the noise comes in.
So one of the proposals to revise BS 8233, our national standard on sound insulation and noise reduction for buildings, is to introduce a minimum performance standard for facade sound insulation.
Brilliant.
So that might take some time, but the number that we have in there for that performance at the minute would probably imply an acoustic trickle vent.
Yeah.
And that could cover situations like this. So there would be some guidance effectively. At the minute, there's no guidance on that.
None at all. Yeah. But it's guidance that I give through my consultancy, because if people are investing in retrofit and a lot of money on the fabric of the building, it does cause problems. I've seen it. And an acoustic vent makes a big difference. You'll still get noise coming in, but it means it's much less likely to be blocked up.
It depends how much money you spend on it. So you might get less. You can have less noise coming through the trickle vent than you do through the glass, for example. It just costs more.
Yeah, absolutely. Yeah, you can get up to like 52 dBA of acoustic attenuation through vents, which is nearly up at party wall level, so you can have quite big impacts on it, but you need to spend the money.
It's a cost. So you don't want to do it unless you need to, and there's a benefit.
What's the general state of play of the acoustic industry at the moment? Is it a sector that's crying out for talent and skills, like a lot of the built environment? Like when you look out into your sector, does it need more of you?
Always. We can never. There's never enough good building acousticians, for example. So we're advertising at the minute because we're always growing, and we're always on the lookout for young, emerging and established talent. But it is a problem across the industry, for sure.
And what's the route into that sector? What was your route? I mean, how did you find yourself doing what you do, Jack?
Just by chance. And that's quite a common route. So I studied thermodynamics and fluid mechanics, and went to work in a old-fashioned manufacturing company making steam turbines for power stations. I wanted to get into the electricity generating industry. I thought everybody's always going to want electricity. This was in the 1990s, but it's still true, of course. Everybody does still want electricity. They just don't want them from steam turbines very much anymore. But actually, that company was up for sale or closure after I'd been there a couple of years, and I thought nobody would buy it because it was so dysfunctional. Every department, it was amazing. People had amazing skills there. But every department blamed every other department for the demise of the company. It had been going down for a long time. So it wasn't a very nice place to work. So I left and did some other things, and then picked up a job by chance doing research in building science department at Newcastle University. I was measuring the heat flow through walls, tiny heat flows through very high levels of insulation. So that was interesting, and for a bit. And then I worked with some consultants who were mechanical engineering consultants, and they were ex NEI. So the company I'd worked for was called Parsons, was part of the NEI group, which had become Rolls-Royce Power Engineering Group. And they were much older than me, or 30 years and 15 years older than me, the two of them. And they did consulting jobs for that industry, but they kept getting asked about noise because so few people did noise in the built environment. And they knew about noise. They were very good engineers and vibration and stuff, so they could read the standards and work out what to do. They weren't really interested in buildings. So I got much more interested in buildings and left to do my own thing. So I started Apex Acoustics in 2006 on my own, and we're now about 26 or 27 people. And this year we just won the Constructing Excellence SME of the Year. Actually, we went employee owned a couple of years ago. So I thought that would be a good business development.
So nearly 20 years old now, Apex. Yeah, that's amazing. Yeah. So what's your day-to-day look like now, Jack? What's you're very heavily involved in standards. Every time I see something, Jack Harvie-Clark appears somewhere in the glossary.
Yeah, I'm trying to pull the industry up by its bootstraps. It's like
Do you get involved out on the coalface much? Are you out there with your mics and suitcases and sight boots on very often?
I don't do that very often anymore. I do get involved in consultancy jobs, absolutely, because there's lots of bits of consultancy where it's you absolutely need to do it. And I'm developing those different types of consulting as well. I'm very keen on the soundscape approach. And that's a new way of dealing with sound entirely. So I'm introducing that to the team as well.
Interesting.
Yeah. So my day is quite varied.
And if you could fix one thing in our industry, the kind of the ventilation sector, the air quality sector, to improve acoustics, what would it be? Like, if you were in control of the levers of power right now, what would be the one thing you try and
I think
correct?
The simplest thing would be if sound levels in dwellings were measured, as you've mentioned, at the end of the building process, that everything else up to that point would fall in line.
Yeah, because you now have a number that's being checked.
It's going to be enforced, and then everything else would happen. So along with the flow rates, it needs to be done at the same time as the flow rate measurements, so that you know you're measuring the system under the right operating conditions. Yeah,
I think that's probably very sensible. Jack, like, I knew this would happen, but we've just swallowed up 2 hours without even trying. Look, thanks a million for spending the time chatting to me. It was really enjoyable, as it always is, mate. And I'll catch you soon. Thanks a million.
Okay, thank you.
Thanks for listening. Before you go, can I ask a favour? If you enjoyed the podcast and know someone else who might be interested, do spread the word and let's keep building this community. And do check out the YouTube channel by the same name and subscribe if you can, as there will be additional content posted here quite regularly. This podcast was brought to you in partnership with ACO, Ultra Protect, Imbiot and Erico, all great companies who share the vision of this podcast. Your support of them helps their support of the show. Do check them out in the links and at airqualitymatters.net. See you next week.